Good evening, folks, again, and welcome to the Fire and Safety Division of Engineers Ireland. Our speaker this evening is Michael Renaghan. He has, as well as being a fellow and chartered and certified accountant, he has been working since 1990 in the ventilation supply business with a focus on fire protection in the last 10 years. Michael does have a great deal of knowledge about smoke and fire ducts, their testing, their classifications, and he has gained a lot of his knowledge from conducting at least 60 tests in the UK, in Belgium and Denmark laboratories. The application of all his knowledge has really led to his most recent research and development project in minimizing the use of insulation while retaining a high level of performance in terms of fire safety. Michael, I think, as they say, the floor is yours if you'd like to take over the webinar talk there.
Thank you for the introduction. Thank you very much for inviting us along tonight. I can talk about this any hour of any day. I love talking about it, and the fact that there are so many people this evening who want to at least dial in and take note of this is testament to the fact that everybody in the organization, the Fire and Safety Division, are taking serious what we're trying to do. So really appreciate that. And I'm hopeful that what we do tonight is going to be helpful. And what I would say is I love questions. So questions are the basis on which we learn. And so please write them down, put them in. We'll answer them all at the end. And the most important thing to know is that we stand ready at all times to answer your questions, not just today, not just when you watch this, but at any stage in the future. You can always contact us because our goal is to deliver safe buildings and save lives and save buildings. Do it right. We can do it properly. So the presentation is about, I'll just go through the presentation here with you now and just get it started. As long as this mouse works, here we go. So just to let you know, Thorduct is owned by a company called Lindab. It was bought by Lindab a few years ago. Lindab is a PLC from Sweden, and it's a very big player in the ventilation market, biggest in Europe in terms of round and now in square. So they've got huge factories all over Europe. The numbers are slightly updated. They're probably about 5,000, maybe 6,000 employees at this stage, 120 branches plus 32 different countries. So what the important thing to take from this is that Thorduct is in a stable that's a very good stable. It's a very serious business that we're in. We know about ventilation, and I think Thorduct is a good fit for this company, and it certainly has been supporting the R&D that we've been working on. Tonight, very quickly, I'm going to go through these points. You'll get a lot of paperwork afterwards, but we're going to talk about the EN documents and integrity, installation, compartmentation, fire types, passive ducts, all our favorite, how to apply what we learned tonight, because there's no point in getting a load of detail if you can't see the reality of it in life. So I'll show you a few animations in that. Certification, CE marking, EN and BS. BS is still floating around. We need to do something about that, but we need to know when to use it, when not to use it. And then there's certain little things that keep coming up that will catch you out. So if I tell you about them in advance, you know what's coming. So that's useful. The normal reaction of staff towards smoke evacuation duct and fire duct is to kind of bury the head. We need to get somebody else to look at this because it is really complex. It's not that difficult, but I can absolutely understand the approach where people want to run away from it. So please hang in with us here and we'll try and get you through some of the details. What we will provide you with, or what Engineers Ireland will send you on, is we have a number of booklets. These are really easy booklets. They're designed not for, how would we say, intelligent people like yourselves. They're designed for people just to look at pictures and gather the information real quickly. So they're very simple books. The Understanding the New EN Regulations is very easy to follow. That's available in PDF. There's another one, the installation manuals. Again, you can get those for whatever system you need. And then there's a technical CPD summary notes. Now that's for the techies, the people who really want to know the detail. And that document is pretty good to keep in your folder for when fire duct comes up. So pull it out. It's got all the answers, all the techie stuff in there, and you'll be delighted to look at that. Very simply put it, there are two types of fire ducts. Ducts are used to ventilate buildings, but in a fire they have two purposes, two types. One is a smoke control duct. So the idea of a smoke control duct is you're going to take the smoke out of the area in the building that's on fire, and very often bring it through the rest of the building to get it outside. We use smoke control dampers with smoke duct to determine how we control the evacuation of smoke. we understand why it's so important to get the smoke out. That's one particular type of duct. It's doing something very specific in a fire test. Then we have, for everything else, we've got fire-resistant ducts. So fire-resistant ducts covers passive pressurization in kitchens. So a passive duct is where we can't use, for example, we can't use fire dampers. It's inaccessible. We're not going to be able to drop test them. So we can use fire duct because it acts like its own compartment. Pressurization duct, again, where we're providing air into a building. So we want to pressurize a stairwell, for example. So that needs to be fire-resisting duct. Obviously, you don't want it to fail in a fire. And then, of course, kitchen. Kitchen is a real problem and has unique risks. So again, we've got to have a duct that's suitable for that application and test it correctly. So we'll be going through that. The standards are all EN 12101-7, 15871. Don't worry about the numbers. They're in the booklet. So you can go and you can see this little chart inside the booklet. You'll always have the numbers. So we have a product standard, classification standard, test standards, and extended field of application. The product standard is the overall global. The classification standard determines how you report your results. So you have 10 different suppliers with 10 different testing regimes, but the classification report levels the playing field. So it tells you how they've performed. Very important document. And then extended field, if you want to do something outside of the test, the extended field allows you. For smoke, there are certain limitations. The maximum size is 1250 by 1000. That's it. So under EN, you can't go bigger than that. And the reason for that is that the testing required for bigger sizes is all about leakage. And it's not easy to mathematically calculate it for larger ducts. As well as that, the volume of air required from a furnace during a fire to mimic 1100 degrees or 1000 degrees is a significant amount of energy and a significant amount of air. So regulating that so that you can measure the leakage is really, really problematic. So it's a problem. It's not possible at this stage. But for fire-resisting ducts, because it's not about leakage, it's about performance in different ways, both insulation and integrity, you can go up to 2.5 meters by 1250 under the extended field of application. And that's a system that's readily available here in Ireland, through Duct. One of them is CE marked, one isn't. Simple thing, the product standard for passive pressurization in kitchen wasn't adopted, hasn't been adopted. It's a technical thing. It's really got to do with manufacturing. But you can get a CE marked smoke extract duct on the market right now. By the way, the law states under Regulation 305 that if there's a CE product available, you must use the CE product. That's the rules. So it is available, and CE comes from the factory production control. So just to let you know all those things. Okay, integrity. Let's deal with integrity. So we have a fire. The fire's raging. We're exhausting the smoke from the scene of the fire. It's passing through the duct. That can be quite hot. That can go up to 800, 900, 1,000 degrees. What does that do to the metal? Well, with all solids, it effectively moves them to gas or along that chart. And so, well, we need to protect all around us from that heat overload. So we just wrap the duct with an insulation, except the performance of the insulation is directly related to the performance of the duct because it's connected to it. So if that duct moves, suddenly you've got a problem. So I just want to show you a very quick example of a problem duct in a fire. Okay, so we have a scenario here where we have a duct that's in a fire. You can see it's glowing orange here, and the fans are connected here to exhaust the air. So the smoke's been exhausted. But you can see the line of the duct. There's the bracket. And what's happened is the duct has become like a snake because of the amount of heat that's going through the duct. Wow, it never happened to you. Yes. Okay, we don't need to see any more of it. But basically, you can see what's happening here. So the temperature is so hot on the metal that the insulation's focusing that temperature on the metal itself, so it's softening. It goes through what we call an elastic phase and a plastic phase. During the elastic phase, it creates a tension, a pressure, a force. And so the duct has to be able to cope with that force pressure. But after the elastic phase, it goes through what's called the elastic and plastic. The plastic phase, it's all soft. So the forces disappear. But at this point, It's no longer being contained by the brackets. So this is a bad design. And of course, if you put an insulation that's very good on a duct, you need to test the two together to validate that the two perform together. Because clearly, good insulation can kill duct, and good duct, or to have a good result, you need a good insulation with a very strong duct or a very cleverly designed and built duct. Okay, so that's what you need to do. Okay, moving on from that, insulation. We need to just talk very quickly here about the problem with smoke. Let's just talk about smoke, then we're going to talk about kitchen. So smoke, the problem with smoke is that it inhibits escape. It is a problem with visibility for you fire guys when you're trying to fight a fire. It's toxic. And then there's that huge amount of thermal energy. The thermal energy has a knock-on effect. So if you have high smoke, you have high temperatures, not only on the fire, but within the environment of the fire. So you guys are going in, or you're sending crews in to fight this fire. You're going in to fight it, but it's hotter than it should be because the smoke is not getting away. And the smoke is not stifling the fire, it's containing the heat. It's exacerbating the heat. If you have a smoke evacuation system, the flame temperature doesn't change. However, the temperature within the environment of the fire radically changes. So it's very important to do that, to have the smoke evacuation system working. So that does make a difference. Compartmentation, we're all very familiar, so I'm not going to really go into this too much, but otherwise, every compartment needs to be its own compartment. We don't want fire breaking from A to B to C to D, E. We don't want that. When that happens, something's gone seriously wrong. If it goes out the window and falls down to another floor, that's a problem. If it goes through a floor or a wall, or a door and out onto a corridor, that's a problem. So we've got proper windows, proper doors, proper ceilings. And where we have ventilation systems, we must have ventilation systems that don't cause a breach in the compartmentation. Okay. Now, there's a very real problem with smoke ducts. And that is that you're bringing very hot gases through a building from the scene of a fire to the outside while passing through other areas where there is no fire. So what is the risk? The risk is a thing called flashover. And I'm going to be quiet for a moment and let this video explain it to you.
There's several different definitions of flashover. The one that makes the most sense to me, it's the stage in fire development in which the contents and the gases reach their ignition temperatures and flames break out almost all at once over all the surfaces. There are a few different types of flashovers that exist. The NFPA now calls all the different types of flashover rapid fire progress. Those different types, the most common is a hot, rich flashover. That's the most common that firefighters run into on the fire ground. The cause of a flashover, or a hot, rich flashover is what I'm referring to, is a term called thermal radiation feedback. Everything in nature tries to find a balance. If I grab a can of Coke, that Coke's going to warm up, and my hand in turn is going to cool off. Same thing's happening inside of a structure. The seat of the fire is growing, the energy and heat that's being created is being absorbed into the material of that room. It's trying to find that thermal balance. Once it can't find that balance, or that balance is exceeded, the material starts to break down, starts to form a gas called carbon monoxide and radiate that heat back to the center of the room. That process is called pyrolysis. Once it reaches the center of the room, it's going to want to try to find a way to go back to the walls, but like a sponge, it can only absorb so much heat. So then that heat then begins to build and build and build until it reaches its ignition temperature, and then it ignites into fire, and you get flames breaking out not only through the gas, but every single surface in that room.
It's all about heat and energy. You have to have heat to break down a solid to a gas. And that's what produces that very volatile gas. And that's what's killing and hurting us this day.
Another type of rapid fire progress, or RFP, is backdraft. That's probably one of the most uncommon types that we encounter on a fire ground. I've only witnessed one in my 33 years of service. And what that is, it's a fire that's generated so much heat and used up all the oxygen in the room that it just sits and smolders and smolders. The heat does not go away, the air is gone, but that superheated gas has been confined and it's just perking and perking, waiting for us to either open a door or someone to open a door or let fresh air in. It mixes with all the gas that is in there. The heat is already there, and when it ignites with an explosive force. The other would be a delayed flashover. A delayed flashover is also very dangerous for firefighters. Picture a house with a fire that began in a rear bedroom. The smoke and energy has traveled throughout the home, filling it with superheated gases. As firefighters enter the home, a hot rich flashover occurs in the rear bedroom. The sudden increase in temperature is enough to ignite the gases throughout the entire home. Firefighters could be faced with gases igniting all around them, yet the seat of the fire is in another part of the structure.
Okay, so we are aware then that flashover is a real concern for us in terms of removing smoke, because ultimately we don't want the fire breaking out in other areas of the building or behind the firefighting crew. So all multi-compartment smoke extract ducts are insulated, and they're insulated to keep the heat on the inside, not on the outside. Okay, so that's part and parcel of the testing. You will see insulation in a lot of places now as a requirement for multi-compartment smoke extract. The other area we're concerned about is a thing called the kitchen extract. So in the kitchen, there is a known risk, and that risk is the grease. So grease will, over a period of time, congeal on the inside of a duct. Now, the issue with grease is that the oils that we use for cooking, most of those have a flash temperature in excess of 350, 400 degrees. However, when you heat up oil and cool it down, heat it up and cool it down over a period of time, you do a thing called oxidization. And in the process of oxidization, you lower the flash temperature down to 180 degrees. So that's a significantly lower temperature at which it will ignite. So the solution for kitchen extracts, the obvious solution is regular cleaning of the kitchen extracts. However, there's no regulation per se that demands that you must clean your kitchens. So the insurance industry and other industries are pushing for this and trying to make it mandatory. However, if you don't clean them, which is what's going to probably happen, or if you do clean them on a regular basis, there's always going to be some dirt the day before you clean them. The risk is that there could be a fire. So the regulation in DW 172 says that all kitchen extract ductwork that is multi-compartment, in other words, it travels across a number of compartments before it gets to outside, must be fire-rated ductwork, and it must also be insulated. By the way, a note to remember, it needs to be fire-resisting ductwork according to BS 909 2017 from the back of the canopy all the way to atmosphere. So you can't have regular duct in the kitchen and fire duct the rest of the way. Fire duct is a full system, so it needs to be that way. So what is the risk? How does this present itself? So we have a shopping center, restaurants in the middle because we like to have a bit of footfall moving past shops. You have a kitchen extract traveling from the restaurant to the outside. Many times it'll cross stores like they do in all of these scenarios. If fire starts, and note this, not a fire inside the restaurant, because inside the kitchen area, all of that's under control. We have suppression systems there. So it's not really that big an issue, but it's a fire somewhere else. The fire starts in another compartment. The result of that fire is it hits the suspended ceiling, goes above the suspended ceiling, and it touches off the kitchen extract. The kitchen extract has grease inside it. It will ignite at 180 degrees. And suddenly there is a danger to our compartment strategy because the fire will break out in every section along the way and back into the kitchen. So that's a real problem. So what we need to do is we need to insulate the multi-compartment element of the kitchen extract as it travels through the building until it reaches the outside to keep the heat out. The ASFP released a document about 6 months ago where they are recommending inside the kitchen that the insulation performance should be a minimum of 30 minutes. So even inside the kitchen, they're thinking you need to have some sort of protection against that grease igniting to aid escape. So that is something that has recently been issued. And again, it's not mandatory, it is guidance, but it's something worth considering or whatever. So that's the risk with the kitchen and the risk with the smoke. So we just need to understand the different fire types. You guys will probably understand this anyway. There are 3 different types. There's a type A, which is fire on the outside. So you have the furnace and you have the product manufactured, built inside the furnace with a sealed duct, so no air inside it, and it's under pressure. So the furnace is here, and that's your test for kitchen, because you measure the temperature of the duct. The other test is what we call a B test. and the B test is where you have vents inside the duct, and they're actually exhausting the hot gases from the furnace through the duct to the outside, and they're measuring the performance of the insulation. And this, the combustible linings test, which is the kitchen one, is done this way. There's a third test called the C test for leakage. It's very complex, so I'm not going to bother with it here, but just to know that there is another type. It's very similar to the B test. Okay, so passive ducts. What is a passive duct? Well, passive ducts are primarily used where fire dampers are not an option, or ducts that have no mechanical ventilation. And so no mechanical ventilation, or mechanical ventilation stops in the event of a fire. So they can either have it or it shuts down in the event of a fire. The idea here is that people would think, well, you know what type of standard should it be? It should be to the EN standard, it should be classified 13501-3. But there's a big question. The question is, do I need to insulate it? There are two views on this, and this has not been decided. And really, it should be determined first. But I know the one that most fire engineers are coming down on. The first view is that there's no mechanical ventilation, so therefore there's no movement of air, not much anyway. There's no risk of flashover, no insulation required. Okay, so what is it there for? I mean, what's its purpose? It doesn't make sense. The other one is that it's an E-rated product because products are rated E for integrity, I for insulation. So it's an E-rated product which is passing through a wall that is rated EI. So the I requirement needs to be maintained, therefore insulation is required. So a lot of people are saying you can't put an E product across an EI wall and think that that's okay, it's unacceptable, they want it insulated. In most places now, passive ducts are insulated. A lot of these passive ducts are used underground where they cross over car parks to the lobby. The problem with car parks now is, and I don't need to tell you this, you know already, is that if you have a car fire, which you are going to have a lot more of because suddenly we have a lot of electric cars, that's going to generate a lot of heat. The ducts are going to be exposed to that. They may radiate the heat. They may cause air to move and cause the fire to spread. So a lot of thinking has to go on about this. It just can't be left like this. People are going to have to come to a conclusion, but you need to seek clarification from the fire strategy team about whether you need to insulate it or not. No question it should be fired up, no question to the standard, whether it needs to be insulated or not. You're going to need the fire strategy team to make that decision. Okay, so let's apply what we've learned here. Okay, and maybe if you haven't listened up until now you can listen because this will make the difference. Okay, so if you want to see the videos that I'm going to show, the video I'm going to show you, it's available along with a lot of other videos on the thorduct.com website, so you can see the animation there. So I'm going to play the animation and stop it at certain points just to make the point. Okay. So here's the first scenario, a smoke evacuation system. So the idea of your duct is that it will pull the smoke from the scene of the fire, and it needs to do it safely through another compartment and throw it outside. So this compartment is protected by having an EI rated product to the rating of the compartment. So again, it's taking the hot gases and preventing fire from breaking out here while the fire is ongoing. Second application, which we're showing here, is what we call a pressurization duct. So in the event of a fire, people are going to go to the escape routes and they're going to try and escape the building. So in that event, we need to provide, specifically when it's very high-rise buildings, this is ducted, so they need to provide air or duct system that pumps fresh air, tempered air from the outside, into the stairwell so that smoke can't migrate to the escape routes. So that duct will cross or may cross a fire compartment, a compartment where the fire is raging. So it needs to be insulated to prevent this air from becoming superheated and therefore becoming a problem in the escape routes. So this is a pressurization duct, and again, insulated to prevent the air inside the duct heating up. So here we have a scenario where the kitchen extract duct is passing through the building and it's passing through a compartment where the fire is. So you can see it here. So if it is uninsulated, you're going to have this grease ignite. If the grease ignites, it'll ignite like fuel along the entire length of the duct and come back into the kitchen. So it's really important where kitchen extract passes through compartments that it's insulated, like in the scenario on the right-hand side, to prevent the grease igniting. So that animation is on the website. So again, it's really easy to explain to your team and to your colleagues what the risk is. You can see it, you can see how it works. So again, that's the application of the knowledge that we have. From a certification point of view, the requirement on the smoke standard says that there should be FPC, factory production control. So that's something that the manufacturer has to have in place to provide you with a compliant smoke extract ductwork. And as a result, they will have a certification and they will have a CE mark as a result of that. The problem with the existing market is there are products, and we have them as well, where it's field installed. So you have the duct, but you have the insulation field installed. There are products that are both insulated and duct coming from a factory where they're CE marked. So again, CE product is a completely different product because it's supervised by a notified body. It's subject to leakage testing. It's subject to a lot of things that a normal product isn't. So again, you'll have less people on site. It's much quicker to install, and you have more confidence in it because you got a CE marking on it. So again, where a CE mark is available, it's very important that you make sure and choose a CE product. Okay. Third-party certification is vitally important for the installer. Again, you're relying on an installer to put it in properly. You can't give a fire door to a normal carpenter and his apprentice. That's not going to work. It has to be installed by somebody who knows what they're actually doing. So we have strongly encouraged in our industry that people become members of the third-party scheme. In the Republic of Ireland, FIRS have what we call boots on the ground. So they have people here. We really encourage people, our customers, to join FIRS. We do not provide our products to anybody who isn't FIRS or third-party certified. And there are a number of different bodies. So again, that's a good thing to insist on, because at least then you've got somebody signing off who's checking that the install is done correctly. Okay, so that's the CE marking. As I say, under Regulation 305, it is the law. It should be there. You need to just double check that it's available. And again, documentation will be provided for that by a third notified body. Now, EN and BS standards, there's a bit of a clash here. So there was a document which again is available to you and is going to be provided later, which was the Technical Guidance Document number 20 issued by ASFP, BESA and AGCAS. And it was published to deal with the questions that were arising. So let me just summarize it in very simple terms. When it comes to smoke, all smoke ducts up to 1250 by 1000 have to by law be EN. That's just, there's no give on that. You may not use BS. Where the duct is greater than 1250 by 1000, the first option is to split, well, actually the first option is to redesign the ducts down to 1250 by 1000. Where that can't be done because of air volumes, etc., split the ducts. So you have what we call a battery. The third option after that is to have BS 476 with the approval of the fire consultant. So he has to sign off and say that that's the right route to go. Okay, now BS 476 is a lower performing duct. It is not tested in any way like EN 136, it just isn't. And then finally, the fourth one is you can construct the larger ducts to the EN construction with the approval of a notified body giving an engineering judgment. And I can tell you now, you're never going to get one because they ain't going to do it. So that's the reality with smoke ducts. For fire resisting ducts, because the standard 15871 has not been officially published in the sense that it is a harmonized standard in CE marking, they are saying that you can use BS 476 by approval of the fire engineer. However, what they do say is that because the EN 13661 testing and classification standards are in place, and the extended field is there up to 2.5 meters for 1250, that EN 13661 should be used. Now, you know and I know, as soon as somebody says you should use that, even though it's not law, that becomes best practice. And in fairness to the Irish industry, they are all trying to use that. Very rarely will they use BS 476. And again, we have tested up to 2.5 meters for 1250, which is a ginormous duct for air. The issue we have at sizes comes down to one thing primarily. We've got dual systems in the UK and Ireland, where we design the smoke and we design the fire as a dual system, regular ventilation and fire. In the continent of Europe, they don't do that. They have the smoke system to stand alone. So that's just something to be aware of. That's why we have the size issues. Okay, so again, you can do it bigger, but you need a project-specific engineering judgment by a notified body. Good luck with getting one of those. Okay, moving on very quickly, the final recurring questions. So the final recurring questions, little things that catch people out. So be aware of this. We've been telling everybody this for the last couple of years, so probably everybody knows. In BS 99 2017, it talks about ducts crossing what we call protected routes and escape corridors. When it crosses a protected route and you're not using a fire damper in the ventilation system, now very often you can't because it's apartments and etc. When you don't use it, you must use fire resisting duct, and the portion that is contained inside the fire compartment must be insulated. Now, the reason that's insulated is because when your colleagues are going in to fight this fire, you generally take command and control in the protected areas. So you do not want a duct above your head or above your colleagues' heads that could potentially have hot gases going through it and isn't insulated. So it's insulated to protect you guys, because we're all on the way out and you guys are all on the way in. So it's very important. That's the regulation in the BS 9 in 2017. The other thing to draw your attention to is smoke control. Sometimes because of the size of the fans, and sometimes because of the location of the ventilation requirement, you may not have enough air. And when you don't have enough air, the fan can get into trouble and it can burn itself out. It can be exhausted without the proper air. So you have to provide what we call makeup air. And so makeup air is considered part of the smoke control system. So the ducts used to provide makeup air have to be fire resistant ducts because they need to stay open to allow air in so the smoke system works. The issue is, do you need to insulate it? And I'm not going to answer that one. You can work that all out for yourself. Okay. And just as a by the by, very important for you, on our website, powerduct.com, we have a lot of information on the various different products and how they're properly applied and how they're properly specified. So all of the detail that you require is on the PowerDuct page, and there's resources, there's a specification guide, so you can make sure that you specify the right product in terms of numbers, etc. There's how to write the perfect spec, frequently asked questions, the top 5 questions on kitchen, on passive, on pressurization, on smoke are there. So please use it as a resource. And you'll find, for example, on the 2.0 specification guide, there's a video, about 6-minute video, that I promise you, if you spend 6 minutes on that video and you're a designer, it'll save you 600 hours in the next year. Promise you. That's my promise to you, because it'll open your eyes to potential of ways of specifying things properly so you don't have space issues and all the rest of it. So we've been working hard on that. So for updates and all the rest of it, it's going to be here. It's a resource. Please use it. And if you have questions that you don't want to ask right now or have problems on a specific job, we stand ready to help you. Even if it's not a job we're going to get work out of, that's okay. I prefer you to get the regulation and understand what you're doing so that you can be clear in your head as to what you're doing. So with that in mind, that's 35 minutes exactly. So I'm just going to stop at this point, if that's okay.
Thank you very much, Michael. I certainly have gained a better appreciation anyway for the area of work that yourself and Barry Murphy's just joining us here. He's a co-worker of yours as well for the Q&A session. We do have a few questions coming in. I myself have a few, and I think you've preempted a few of mine as well there in your last few slides. I do have just a question in relation to see if you've done any post-fire or real fire analysis or findings, investigations of a system in a building. I'm just wondering, do you have any experience of that yourself?
Very good question. And Actually, I've had an experience with this where I got the life frightened out of me because we got a phone call on a Friday afternoon that there was a fire in a building that we had put our smoke evacuation system into. And I thought, oh no, because you know what it does in a fire test, you know it works, but you're nervous, it's natural reaction. So I had to fly to this country on the Monday, had to go before the fire team, had to examine it. And what they said was that the only thing left in the whole building, that was one floor, was a student accommodation. Everything was gone. Everything was gone, except the smoke ducts. And they had stayed in place. They had done exactly what they said on the tin. And their concern was they were going to rebuild everything on this floor. Did we need to replace the ducts? And we did, but they were in great shape. So that was the experience that I had. In a fire test, and this gives you a bit of confidence about the product, when you test to the EN standard, they bring the temperature up to 1,000 degrees. Now, in a normal room goes on fire, after 30 minutes, you run out of fuel. But in a furnace, there's no end of the fuel. Maybe the Russians might be turning it off, but we still got plenty of it. And they pump it in, and the fire is kept up to these temperatures for full 120 minutes or 90 minutes or 60 according to the specification. So it's very unique. It's the worst case scenario. The product works every time. It's really good. So that's my experience. What I do know is that products lean towards where the temperature came from, but because of the way that they're built, they don't break. Their integrity doesn't break because they're tested under pressure, under negative pressure of 500 PA on a closed duct, and on an open duct, which is smoke, it's got 3 meters per second. So that's with the fire off. So yeah, the experience has been a really good one. Not one I want to experience too often, honestly, but I know it works. I know it absolutely works.
Just then, post-installation wise, do you ever go back and review your systems, or any snaggings in it in terms of maybe somebody has torn down the installation on it, not necessarily knowing what it's all about? Do you find any of those callbacks, I suppose, really?
That was a very good observation. And what happened, what we learned very early on, this is about 5 years ago, we discovered that people were coming to the systems and cutting holes and connecting to them. And the new doctor or the new service provider didn't know what the product was. So we make a big emphasis on putting labels. I know it's not aesthetically what you want, but you got to put a label on that's very clear. Don't touch this. This is what this product is. Any interference, you must notify it back to the management team. So labeling is really important. And we learned that early on. So all our products have a label, and their installers are told, go back, label, let people know. If it's a kitchen extract, let them know, because if they'll know not to interfere with it. If it's a smoke extract, don't touch it. If it's passive, you know what it is, so you don't have to go back to drawings, because our nature is not to go back and check. If it's fire, leave it alone.
Okay, there's a few other questions here online as well. What is the largest duct size available for multi-compartment scenarios, i.e. width and height?
Okay, for smoke, 1250 by 1000, because that's the regulation. Can't do any bigger. We've put in bigger systems by splitting the ducts, so you end up with 2 ducts side by side, independently supported. The other, for fire, for everything except smoke, the biggest size is 2.5 meters by 1250. And if I can add, for single compartment smoke evacuation, we have 1900 by 1700. We did specific tests for single compartment. So in the single compartment, we go 1900 by 1700. I need to check that. It could even be bigger now at this stage, but we can do single. Multi is limited to 1250 by 1000. And then for fire, 2.5 meters by 1250, and under BS 476, 3 meters square. Sorry, 3 meters by 2. Sorry, 3 meters by 2.
No problem. Another question there, it's split into 2, but I'll call it out in one. When using multiple fire and smoke dampeners, must they have an addressable control panel? And can the panel be simplified to close, reset all dampeners at the same time?
Well, I'm going to say one thing, and then I'm going to give it to Barry, because Barry is the expert par non on this. The first thing I want to just say, to prelude what Barry's going to say, is smoke dampers are only installed in smoke duct. You do not put a smoke damper in a fire duct because it's potentially closed or open. A fire damper's default is closed. A smoke damper's default is either open or closed. Smoke dampers only go in smoke duct. They do not go in regular duct. And now, Barry, it's all yours.
Thanks. Yeah, so I'm just going to just read through that again there. Yes, so must they have an addressable control panel? So the regulation, there's not a regulation specifically governing the control of the system at the moment. A lot of this is down to specific projects and how, so typically what you will see from a practical point of view, if you have a project with a large number of dampers on, it's not practical to monitor and observe each one of them if you have 50 dampers in the building to know where they are location wise. So an addressable panel is very much the industry standard and what's expected when you get to larger jobs. We have had examples of smaller projects where maybe 1 or 2 dampers are connected directly back to the fire alarm, and then an IO is killing the dampers, killing the power to them. In that case, it's easy to check them afterwards because you only have 1 or 2 locations to go to. Whereas with a bigger system, you have much more complicated areas and locations to try and identify where you might have a problem. And then secondly, can the panel be simplified to close, reset all dampers at the same time? Yes, absolutely. So a lot of common projects we look at, it would be, a good example might be, say, a hotel or an office block, the damper throughout the building. The typical cause and effect strategy would be to close all of the dampers in one action. So if fire alarm goes off, it gives a signal to the control panel for the dampers, and that shuts all dampers simultaneously. Most panels these days would have a facility to test individual dampers through the panel or test all dampers at the same time. And then you go the opposite end of the scale if you need to go with complicated strategies for the likes of healthcare facilities, maybe for horizontal evacuation strategies and the likes of that. Then you do have situations where you can close down certain dampers in certain zones depending on what the alarm is.
Thank you. I like this question. I didn't type it. When it comes to joints between various lengths of fire rating ducting, what characteristics should we as inspecting engineers be looking out for?
Okay, another excellent question. And the problem there is you don't actually get to see them pretty much after they're closed because a lot of them have insulation field fitted. So that's a bit of a difficulty. First thing you need to do is you need to get the install manual for the specific product. So get the paperwork. A lot of the paperwork's good, some of it's not so good, but try and get your hands on the install guide and then find the instruction. Hopefully it's a little diagram that shows you how it's joined together. The only way you'll know is if you break it open. They're not going to be able to do that. So what I would suggest is you need to ask, is the installer third-party certified? Now, if you've got that, that's a huge load off your back because there's somebody checking their work. They're trained, they know the product, they have the install guides, and they're following along. If they're not third-party certified, it falls back on you. Now, that's a real problem because how are you going to break every joint? And the fact is you can't. You need to be there while they're building it, which isn't always practical either. So again, they can also, when you're doing it, you know how it is, when somebody's looking at you, you do things a little bit better. That's our human nature. And when somebody's not there, so third-party certified is the route to go. And what I would suggest is maybe, we had this experience, Barry and myself, previously where we had large projects and we did a mock-up of the fire dampers. We did a mock-up of the penetration. And we said, there we go, everybody was involved, everybody knew. Maybe that's a suggestion to you if you're involved early on. But if you're checking afterwards, it's really difficult. The less the installer has to do, the better. But when it comes to fire duct, they play a critical role, unfortunately, and they have the potential maybe to get it wrong. It's difficult. Sorry, that's not the answer you want. But
no, I agree with Michael as well. It's kind of the intervention early in the project, meeting the guys on site, doing the first of kinds, the benchmarks of the penetration seals, be it for the ductwork penetrating or the seals, and making sure that we get in there early and you do an observation and we get agreement and buy-in from everyone that they're doing it properly. And the installers that are third-party certified, they're getting regular refresher training and updates when they get new employees. So it's very regularly that they're in and out to our training center to get training and get updated on any changes or any queries or just refreshing the whole process.
have another question here, and if I had a penny for every time this was asked to me as a fire officer, I'd be a rich individual now. But it goes along the lines of, through a protected corridor, does the fire rated duct and insulation need to extend a certain measurement past the EI rated wall, or just to the face of the outer leaf of each wall?
Based on BS 909 2017, it only demonstrates it within the compartment. So the wall, the two walls effectively, there's no reference to a specific distance past those walls. So it's just to the wall. So if you think about the fire is in there, or the fire is trying to get in there, it can't get in because that protected area is protected. The rest doesn't matter. There's nothing. I'm not saying it doesn't matter. I'm saying that's a bad choice of words. There's no regulation in BS 99 which says you must go 1 meter either side. It doesn't say that at all. So there's no guidance that I'm aware of in any documentation.
Perfect. And there's a cheeky question here, but I'm going to ask it anyway. Are there Swedish testing facilities available for Irish engineers to visit and observe?
We have a research and development lab in Sweden, and we could bring you there, but we'd have to kill you afterwards. So just don't allow people to see it. So we have a lot of things that we test. But what I can do is, and I'm happy to do this. Barry and myself and a number of other people in Lindab are part of the research and development team. So we've actually developed a new product which we've launched, so people will find out about it shortly. But we're doing tests in Copenhagen. So Copenhagen's a 2-hour flight. There's lots of direct flights. So if there's a team of people who want to see a test, what I would say is you'd have to sign non-disclosures. You'd have to accept that some of our tests don't work. That's part of testing and research. But very happy to bring you along. And we'll even bring you out for a meal afterwards. It's not a problem. Happy to bring you along if you're interested. And I promise you, it's an eye-opening experience. You will never look at ductwork the same ever again. You'll never look at a door the same way again, or a window when you see a real test. So yes, we're very happy to invite people to come along. And, you know, regardless of whether we get work out of it or not, because it's a commercial business we are, the reality is we share the knowledge, and knowledge is a good thing. And if it saves one life or saves one building or saves something, you know what, that's a good thing too. The answer is yes.
Perfect. I'm absolutely delighted now I asked that question, because there has been, we've been known as a group to go on tours around.
No problem. Well, we do our testing in DBI, which is Danish Safety and Fire Institute. And they have great rooms there to do presentations. You'll get to see a lot of stuff. It'll be, you know, if you ever want to go, by all means, they would love to have you over. And if we organize a test at the same time, that would be magic. That would be magic. Yeah. Absolutely.
Well, on that high note, I think we'll leave it there for the evening. Just to say thanks a million to Michael and his colleague as well, Barry, for organizing today's event. It was much appreciated. And I certainly did even learn something myself. So from all of us here in the Fire and Safety Division, thank you very much.